Today we are going to talk about how can we interact with industrial devices using the Elixir ecosystem. This topic was covered like in the last Elixir Conf, but I feel like I rushed like to a little bit. So I think I didn't explain very well the most important thing, that is how to use the code, or the example to be more like to describe better the usage of the code, the libraries. So yeah, this will be the talk. So let's get started. Yep. First, let me introduce myself. My name is Aldebaran Alonso. I am an embedded engineer at Valiot, which is a software company focused on Industry 4.0. We are focused on optimize the production process by using AI along with IIoT. And my main job there is to maintain and develop new features of our edge device, which is the one here, this hexagon right here. And yeah, this device is a nerves-based device, and we currently use it to post the data, parse real-time data from our sensors, execute edge controllers, and also to talk to industrial devices such as PLCs, motor drivers, and SCADA systems, and so on. And this final concept is the one that we are going to focus on for this talk. Um, this is the content that I would like to cover. We will look inside a common problem for the startups and makers when developing products focused on the industrial environment. And this is how to connect to industrial devices. How can we talk to them, share data, and do interesting things with that. First, we will discuss this problem along with a brief introduction of industrial communication protocols, covering their importance and features. Then we will talk about our experience and workflows for adopting such as industrial protocols in Elixir, focused particularly on ModBux TCP and LPC UA, with a little demo, which will be a Nerves device that will run a server and a client of both protocols. Finally, we will cover the state of art of some open source projects that support several other industrial protocols, as well as future of our work. Yeah. But first, a little disclaimer here, always be very cautious and responsible when accessing or programming industrial devices, since they control many kind of equipment and loss of properties, um, production, or even life may be possible. So always be very careful with dealing with this kind of devices. They are really sensitive and maybe a little risky to do any change in them. So please be very careful with that. Well, let's talk about the problem. Let's imagine that we are developing a product. So we have already the idea of what we're going to do. Like we are going to make a sensor that measures temperature, humidity, or any variable that we need to measure. We also need to do maybe some machine learning to make some signal processing or pattern recognition to generate value for our customer. So we can identify these requirements. We need software to measure the physical variables. We need a user interface to create a way to the user interact with our device. We need also historical data to store like logs, alerts, events, or any problem that we have in the field. We also need machine learning, maybe to create this pattern recognition or control maybe a motor or trigger alerts or something like that. So we have this amazing ecosystem, which is Elixir. We have the Nerves framework to create or to make our product, our Elixir project into an embedded system. So we can also use Phoenix to create this UI based on a server inside of our device. We also could use Scenic to create more like a physical screen to configure the device. We can also use Ecto with all in their related packages to store the data that we talked before. And we can use Action to help us with the machine learning stuff. So let's imagine that we are designing this flux capacitor. So we have already designed this thing with all these frameworks that we already have, but what will be our next step? Having this device already developed, well, we have to sell it. However, the most important thing here is that if we manage to find our customer, this customer, their main reason that we will look for our device is to interact, to make the interaction between our device and the field of, well, all the machinery that he already has deployed. So this is the problem. How can we interact with their devices? And moreover, their devices look something like this: huge, enormous, and very intimidated devices that maybe may cost like millions of dollars. So how can we interact with, or how can we expose our data and share the data that we are generating to their machines? This is the problem. So we have to look inside and see which is the proper controller that it's making all the things move. So yeah, if we can see right in this part, we can see that there is almost for sure a little room, which may be called like control room, and it's full of cabinets with electronic controllers in there. So if we open one of these cabinets, we can see that there will be controllers and like PLCs in there, or maybe drivers, motor drivers, or something like that. So however, most of this device doesn't support common communication protocols such as HTTP or WebSockets or MQTT or anything like that. They use industrial protocols for safe real-time communication purposes. And that's the next topic that I would like to cover: industrial protocols. So, however, these protocols is like the human language. There are tons of them, and they have different syntax and different purposes to communicate the data. So the selection of which protocols we are going to use depends on the requirements of the application. For example, we may be time restriction or security issues for remote accessing or something like that. So there are a ton of things to consider when choosing these kind of protocols. However, considering our context and that there is already machines that are running on the field, they may be restricted with some protocols. So choosing our protocol may depend highly on the protocols that their machines already support. So that's the problem, and we are going to discuss how to add for our Nerves device support for that protocol. So now we will discuss three possible ways that we know. The first one is a full Elixir implementation, which we recommend when the protocol is quite simple to implement. Therefore, it is an open specification. For example, ModBus is a protocol developed on 1979 by Modicon to communicate electronic devices together. It may use multiple physical interface, such as serial interface with ModBus RTU, or we can use Ethernet or Wi-Fi with ModBus TCP. So fortunately, we don't start in an empty from scratch. Basically, there are already packages that we can use. For example, we can help us with vintage net to manage the Wi-Fi or Ethernet. Also, we can use GEN TCP, the library from OTP, or we can also use circuit UART to handle the serial interface. So we basically take those libraries together and manage it to create this library, which is an open source library and everyone can get access to it. We call it ModBux, and this library was designed to handle network and serial ModBus communication, which is the master and slave behavior. Another important thing is that the circuit UART exposes a behavior which is called framer that helps you handle the frame and calculate the CRC and handle the errors in a proper way that maybe in other libraries will be a little difficult to manage all the binaries by itself. So we can also use TCP, and both behaviors are available, the client and the server. So depending on your application, you can either design your device to be a server and expose the data in a friendly way in which the other machine can access whatever it wants or whenever it has time to access to your device and manage it and handle the errors in a way that it can be handled by itself, and you only expose the data as you want. The other way is to be a client and write directly to the machine, which is a more risky approach. So for a recommendation of mine is that always try to be the server, the slave, whenever you want, whenever you want it. So here are some benefits of using ModBus. For example, it is, as I said before, an open specification, which is really easy to implement and understand. It is well documented, doesn't require hardware constraints because it uses like speeds that don't even need really expensive hardware. And also, it is widely used by many devices on the market and legacy machinery. This is because, as I said before, ModBus is like from the 79 years old, 40 years old. So almost every device has the ability to talk in ModBus. So it is a good way to interact with old machinery because all these devices understand this protocol. But also has the disadvantage, such as there is a lack of any security. Like, for example, there is no SSL or TLS. So everyone that is hearing the network can understand what you are asking, what you are sending to the devices. So this might be for some applications a problem. So another thing is that it's really difficult to model a device memory or the device variable with this protocol because it only supports two types of data. One is a Boolean and the other one is an integer of 16 bits. So if you want to encode a float, you have to do it manually, and you have to do well documented on like a table or like an Excel or something like that, and do like a address mapping of all the variables that you are exposing in order to your customer interact to your device. So yeah. The next way that we know that can help you to support another device is with NIFs. However, this might seem risky because if a NIF fails, the whole VMs will crash, and this is not acceptable for this kind of applications. Fortunately, there is a safer option. There is also a safer ways to use NIF, we can use like Rust or some other languages that help you handling errors with in a better way than C or C++ way. So, however, I really recommend you to use a more safer and controller way, which is the next one that we're going to talk about, which is Elixir ports. Here we have to write an Elixir wrapper, a library like a middleware, and use an Elixir port as an interface between them by using like a standard input and the standard output as a communication channel. And it involves a little bit of more effort, but it's more controlled and more safer, in a way that if anything anything crashes, and supervision tree can help you restart the whole process. So yeah, however, the most important thing about using ports is that you have to handle the cross compilation. And in a common workflow, and Nerves handles all the cross compilation. However, when you are dealing with ports, you have to do all the cross compilation process. Therefore, we highly recommend you to choose wisely which of your libraries wants to port to Elixir, to the Elixir language. So basically, you have to choose this library and this library shall be shall have a good documentation cross compilation in order you to know how to point all the environment variables, how to run the CMake and all that thing that Nerves handles, and make you do this thing like seamlessly. And unfortunately, there are a lot of packages that help you with this task, like for example, Elixir CMake. CMake helps you cross-compiling huge packages. Also, Buildroot uses these kind of packages to build all the nerve system. So there is this kind of packages are already known for embedded Linux environment. So there are already wrappers, Elixir wrappers for this kind of packages. So we highly recommend you to use them for this matter. And for this kind of application, we managed to implement OPC UA as an example of using ports. So this protocol has many advantages, such as secure communication. This also can be using the certificates and all SSL and TLS abilities. So another feature is that there is a simple way to model the data. For example, in this protocol, you can use a more object-oriented way to model your device in a way that you can expose like the temperature and expose how the data is encoded. Also, it can also has like an status related to the device. You can share with the machine if the data is reliable or not, and we will show how this is done in the demo. But yeah, this is way easier than ModBux, and way more reliability, more described than in the ModBux way. Also, it has several ways to communicate. For example, it has a pops-up behavior. There is no need of pulling the data from the server. this pops up behavior helps you to notify whenever the data has changed. So this pops up behavior in OPC UA is called monitored items. So yeah. But as I said, there are a lot of pros for using this kind of protocol, and with this disadvantages also came with more complexity in the source code. So there is no way that, or it will take a lot of effort to create a full Elixir implementation. So for this purpose, we choose to to use the Open 6251 library, which is a C library that has a lot of commits and has a lot of maintainers, and moreover, the maintainers are several companies or universities that makes that maintains the code. So an important thing of when you are trying to support a new protocol is that the library that you are going to rely on needs to be alive, like to be to in order to help you with maintaining the code. So that's the reason that we choose Open 62541. And well, we called our library, which is a wrapper of this library that I talked before, OPEX 62541. This is also an open source library. It has the following features. We have OPC UI server and client. We have the monitored items. We have the way of modeling the data, and also we have the secure communication for encrypting the messages. So yeah, we are going to talk about the demo right now. So this demo, I call it Denom, which is the demonstration of Elixir Nerves with OPC UA and ModBux TCP. First, I'm going to describe how is my my setup in the hardware. I have a Raspberry Pi 3, which will be running a server. And this OPC UA server will handle two variables, which is the flux energy and the DeLorean speed. One of them is actually like modified by another microcontroller, which will be like emulating the electronics inside any device. And the other one is handled like in a GEN server, so it's like changing in real time without the connection of the other electronics. The other server that is running in our device is the ModBux TCP server, which also has two different variables. One is handled by the Elixir application, and the other one is handled by the Arduino. And as I said, the Arduino has the purpose of the Arduino is to emulate the electronics of any device, like creating like a sine wave for one of the variable. And yeah, we are using the serial communication, the USB, for sending like JSONs, and in that JSONs, the data will be sending them to the Raspberry Pi, and the Raspberry Pi has the backend to handle the JSON and parse the data and update the sensors registers. And these servers will expose their services to the Ethernet interface. And my computer will be emulating like a PLC, and the PLC will be the client, the OPC UA client. We are going to read-write the data from the Raspberry Pi in both in the ModBux channel and the OPC UA channel. For this, we are using graphical interfaces. We also can use the library, but I think that seeing more graphic will be better. And I will be using SSH to communicate to the Raspberry Pi and see how the data is moving between them. So we will be using both the Elixir way and the graphical interface with other clients and commercial clients. For example, OpUA Expert is a well-known client for OPC UA, and I will describe a little bit of the usage of this software, and it's quite simple. And the other is an open source client of ModBux, which is this one. Okay. Also, the demo is right on my GitHub, so anyone can have access to it. So yeah, let's get going to the demo first. I will describe the code. So this is a common application of Elixir, which starts with the application model, in which there is only a supervisor that will spawn the ModBus server, the OPC UA server, and the UART supervisor. So the ModBus server uses the ModBux server, as I said before. So for the ModBus server, you have to create an address mapping. As I said before, ModBus is like quite old, so you have to create like a table of address and in that table you have to map the data that you shall be exposing. Also, you have to declare the port that you are going to be exposing. For ModBus, the common port is 502. But if I am running in the host, since I am using Linux, these ports are not commonly available, so I change it just for developing purposes. And yeah, also the server has like active mode, in which if the active mode is enabled, the server will be sending messages to the parent process. So in that way, for example, here, I will explain it a little bit moreover. So yeah, these are only functions. For example, address map. Here is the map, as I said, of the addresses we have, with an atom of C for coils and an atom of HR for holding registers. These are conventions of this of ModBus protocol, and I have defined different parameters. For example, this is the power address. This address is the one that I'm going to be asking with the client, and I'm going to be reading this address to see the current state of this server. And yes, as I said before, and the holding register is like how do I say it? It's an integer of 16 bits. So the data that I'm going to expose is a float. So I need two of the holding register because the float is 32 bits. So I have to handle the address, the starting address, and the end address, like the MSB address and the low SB address. So I initialize them in 0, and yeah, with these functions we can start the server. And yeah, so yeah, there is a function here which also be exposed. This function will be used by the UART device handler. Here is the way that the Arduino will send the data to the server. The Arduino UART device will call this function, and this function will be updating the server state in this way. First, I will decode the data in a way that can be handled in these two separate registers, and then I can update the server safely. So here, when updating the device, I also use the logger to see, and we will see it on the Raspberry Pi when changing this device. When I connect the Arduino to the Raspberry Pi, this log will be prompt, and we'll see how the value is parsed in hex, and the data that is going to be writing to the server. Also, as I said before, this server will be in an active mode. So when the client sends a write command for the coil, when when the client forces the coil to 1, the DeLorean will be start the log will prompt that the DeLorean is starting. This is like a running, and when the client sends a 0, like an off, the client will be the server will stop the DeLorean. So also this has a logic. If the DeLorean is off, the DeLorean starts. Therefore, if the DeLorean has a 1 and the client sends a 1, the DeLorean will not prompt this callback, and will go to the catch-all handler. And the same way with the off command. So the other one is the OPC UA server, which has a more complicated way to describe the variables, but it's more like an object oriented, as I said before. First, you have to declare the namespace. Well, as I said before, we are using the OPC UI server. Yeah. So for this library, I am using the use macro. Therefore, there are some callbacks that you have to implement if you want it. For example, the configuration callback, the address space. Here you can declare all your variables, like the table of your exposed variables, and the configuration. For example, which port are you going to use? The host name, the security. Here you basically run the configuration. For example, here you can I think that here, or maybe here. I don't remember very well, but for this case, okay, maybe I declare it right here. Yeah, Dynamo PC. Yeah, let me see if I can search it right here. Okay, no, it doesn't matter. It runs with the default values. So yeah, you have to declare the callbacks to start your server. And here I declare the variables. First, I declare the namespace that will be the sensor. Then I declare the object as flux capacitor, and then which variables has this device, which is the flux energy, which is the DeLorean speed, and how they are related. For example, when you create this variable node, you have to describe which will be their parent node. So in that way, you create the address, and also you can declare which of them can be used as a pub/sub communication. It also has, for example, here in host mode, you can use like the certificates to be more in a secure communication way. And also it has like, as I remember very well here, I create like an internal communication, an internal message sending when the GEN server gets this message every second. It will like increase the speed basically, and every second this variable will be increasing by 1, and when it goes to 80, it will prompt the log that the heat is breaking, and the value will be 0. And this is basically the logic of the variable, and here is the function that updates the server. So yeah, basically this is it. And here is the UART supervisor. The UART supervisor has the devices supervisor, so in runtime you can plug and play with any Arduino that you can connect. The UART event is a more recent library that the Nerves core team has developed to handle UEvent messages. So you expound both of them, and basically the device supervisor is a dynamic supervisor. Is nothing important here. The UART event basically detects when an Arduino or a Teensy or something like that, it's connected to the Raspberry Pi, and when it detects this thing, it basically sends the commands to the dynamic supervisor to start a device. And yeah, basically that's the thing. Maybe I shall share with you the MCU firmware, which is the firmware that is running on the Arduino. This one is like I use platform.io to compile the firmware for the Arduino, and it's quite simple code. It's basically a Singway generator and a random signal generator, and basically I'm creating like a string, a JSON, and basically send them to the UART interface directly. The other thing that I don't share with you is the UART handler. Each time that the UEvent detects a device, it prompts or it spawns this GEN server with the dynamic supervisor, and this device basically waits for the JSON, decodes the JSON, gets the data from OPC UA, as I mentioned here. It has two different keys, one for OPC UA and another for ModBux TCP. And here I basically get the new flux energy and new stored power. And here is the interaction between both servers and the Arduino. Here it uses the function to update its value, and basically it logs which device has sent the message and the message itself. And if there is any errors, it will be prompted. Also, this GAN server handles the reconnection of an UART if there is any problem with the cable or something like that. So as I said, I have an Arduino connected to it. I'm going to connect the Ethernet so we can SSH to it. I have to say yes, and yeah, in the Raspberry Pi. So I'm going to bring lower tail dot attach just to see how it's running the data. So if I connect the device, the Arduino here, all these logs are prompt. And yeah, we can see how the data is sending from the Arduino and how is updating the ModBus server in like forcing the holding register, the address that we shared previously, and the data that has been writing into it. For example, this one. So now I'm going to share with you, for example, here is the ModBus TCP client. It's a really simple UI. And here, for example, I'm going to write to the slave one. The slave one is an address that I just, excuse me, that I just described right here. Slave ID, I just put it like 1. And the address is for this variable is 4103. And however, the coil, the address is the number 1. So for this matter, I'm going to send to write the coil register number 1, and I will turn on and off the value and transmit it to it. So for example, I will send an off. The data has been received here. And well, I believe that is already off the DeLorean. So if I turn it on, here the logs prompt that is starting the DeLorean. And if I shut it down with this command, the command is stopping the DeLorean. I think I have a typo there, but yeah. So yeah, this is the way that you can, that the like a PLC sends the data to your device. It can also use different functions like writing holding register. For example, if we can read the data that is on the ModBus TCP server. For example, the address was 4103. I believe that it has the size of 2. As just to remember, we are using a float. So here is the data that was exposed. The data right here is being updated. So for example, here is the data that we have written previously. So if we pull the data off, the data has changed. For example, here the data is I believe is something like this, or here it is. So yeah, this is the ModBus communication. And for the other communication for OPC UA, we are going to use OPC UA server. Here is really simple. It's a client really simple to use. You have to basically add the servers. There are 2 right here. One is the OPC UA, which is running on the Raspberry Pi. Yeah. Here, the Raspberry Pi doesn't have right now the ability to use, well, it can use the certificates. However, I would like to use like the Nerves key and all that thing, but Currently, the Nerves key is not supported with this library. However, you can store the certificates in a local folder, local directory. So you can also use it. But and I will, if I have time, I could change. I could show you with my local computer. Yeah, so you have to select this one, and here will be prompt the server. You have to connect with this button, and here it appears all the objects that are running on that server. For example, here is the server and has a lot of information about it. For example, the runtime, the capability, the communication capabilities, and all a lot of things that are uh, prompt by default by using this library. And here is the data that we are exposing to the machinery. For example, if we add right to this window, the data will be prompt like in real time. And here the DeLorean key, as I said before, runs from 0 to 80, and when it comes to 80, it will restart the count. And here is the data from the sine wave. And as I said before, this kind of communication is really is better because it has a lot of metadata that helps you handle the data. For example, when the data has been gathered, the data status, I can send them like it's a bad data, and maybe the client will do something or some logic to handle these kind of errors, and the data type, the value, and which server has them, has a lot of different metadata that can help you with a lot of things. And yeah, for example, I'm going to disconnect the Arduino, and basically this one stops updating because this was the value right on the Arduino. And the best part of using Nerves is that you can also run your application in your host computer, in basically Glover dot, and will basically be almost the same as as your embedded system. Here I prompt the device, and it is running right the same way as the Raspberry Pi. So here I can create or connect to my local computer, and as I showed previously, here in the initialization of the server, I defined that if I was running on my host computer, I will be using more the secure way of this communication. So if I show here, it prompts the different communications available. So if I maybe grab here, also one disclaimer here, my certs are a little uh, outdated, so it prompts like several errors. Okay, I think if I connect here, yeah, but certificate type invalid, so I basically see that here I will accept, continue, ignore. It prompts the same error that the certificates are not available. So here I'm connected. Disconnect here, and here connection. Yeah, and here is running the the data from the server. Oops. So here is OPC UA. Like the number right here is the one that has been updated from from the Arduino. If I disconnect the Arduino from my local computer, the same happens with my host. It stops running the data real time. So yeah, this is the demo. Finally, we are going to talk a little bit of another libraries that we have been working on. For example, this is AVEX. It's designed to communicate with Allen Bradley PLCs or Rockwell Automation PLCs. SnapX7 library is used to communicate with Siemens PLCs, and there is also another library to communicate with Allen Bradley PLCs, which is called Scrub. This was developed for Very Possible, a company that also is like working in Industry 4.0. And future work for us, we are really interested on working with Canvas because it's like really a lot of efforts in Linux to support this communication. Also, it's well known that a Raspberry can use this bus with a little of extra hardware. But yeah, we have developed like a VintageNet CAN for handling this bus in a way in which you can connect to them like with a socket. And yeah, we are looking forward to support CanOpen protocol. And yeah, basically that's it. Thank you all for hearing me, and yeah, that's it.